question is from GATE 2016 Mechanical Engineering paper set 2, question number 24. The following data is applicable for a turning operation. Length of the job is 900 mm. Diameter of the job is 200 mm. Feed rate is 0.25 mm per revolution and optimum cutting speed is 300 meter per minute. The machining time in minute is dash. Let's find out. I'll start by writing the given things. Length of the job, let that be capital L, is given as 900 mm. The diameter is given as 200 millimeters. Feed rate is given as 0.25 millimeter per revolution. So pay attention to the unit that is given, it's millimeter per revolution. Cutting speed V is given as 300, it's in meter per minute. We have to find out the machining time. Now because everything else is given in millimeters, so we'll convert cutting speed also in millimeter per minute. It will be 300 into 1000, that is nothing but 3 into 10 to the power 5. This is V, cutting speed, in millimeter per minute. We are being asked to find out the machining time. Machining time simply will be the distance that the tool will travel, that is L, length of the job, divided by the feed rate at which the job is being fed to the tool. But this feed rate is not the feed rate that is given in millimeter per revolution. It should be the feed rate in millimeter per minute, so that we'll get the answer in minutes. We are calculating time, we should get the answer in minutes. If this is millimeters, the distance, we should have the speed here, which is feed rate in millimeter per minute, right? So this FR that we have to calculate will be calculated using F and the rotational speed. So rotational speed has to be calculated, which will be RPM, and that will be calculated using the cutting speed. Now for the tool, cutting speed is given V. We can calculate the RPM by using V is equal to pi d n by 60. This is when n is in RPM, revolutions per minute. We get V in meter per second. But here we have V already in meter per minute. So we can calculate n as, we don't have to divide this by 60. We'll directly take V by pi d. We have converted V in millimeter per minute already. So let's substitute that. It is 3 into 10 to the power 5 divided by pi into diameter is given to be 200 millimeters. So just multiplying this, we have 200. This is equal to 477.7 RPM. Let's use this n to find out the feed rate. So feed rate will be equal to, we have to find it in millimeter per minute. So we multiply this feed rate given in millimeter per revolution to the RPM. So we'll have F into N, which is nothing but 0.25 into 477.7. Let's look at the units. What is happening with the units? Millimeter per revolution into revolution per minute. So ultimately we get FR in millimeter per minute. Now let's substitute this FR here and directly find out the machining time T. So machining time T is 900 by 0.25 into 477.7. Machining time after calculating this in digital calculator will get as 7.539 minutes, which is almost equal to 7.54 for 2 decimal places. Let's go back and fill in the answer. The machining time is 7.54 minutes. To learn more about such machining operations, you can refer to the NPTEL video, Practical Machining Operations, Turning and Shaping and Planning Operation from the course Mechanics of Machining. This course is by Professor Uday S. Dikshit. He is from Department of Mechanical Engineering of IIT Guwahati. I hope this solution will help you clear your doubt. Thank you.